9.5, polar coordinates, what you should learn. Plot points and find multiple representation of points in the polar coordinate system. Convert points from rectangular to polar form and vice versa. And then convert equations from rectangular to polar form and vice versa. So before today, all we ever worked with was a rectangular system. So we had a rectangular coordinate system, which looked like this, right? X and Y. The points were X and Y, right? We went X and Y. X left and right, and then Y up and down. On a polar system, in a polar system, we're actually going to do R and theta. So a lot of times you see like rings, and those are that's your radius. So a radius of 1, a radius of 2, a radius of 3, and go on and so forth. So if I give you like 3 and let's say 120, that's a polar coordinate. So what this is I'm asking you what angle we want. So with theta, right? What angle is it? So 120, we know this is 90, this is 180, 120 is over here somewhere. So we're going to be on like this pole, the 120 pole. And then we're going to go, what's the radius? The radius is 3, so we're going to go out 3 from that spot. So 1, 2, 3. So that would be 3 and 120. So it's the radius, like which radius you go to, and the theta, what angle are you going to. So that's what this is saying here. So right, R is the directed distance, like what radius you go, and then theta is the directed angle. So how much of an angle do you want? And we're going to do R theta. So we're going to plot some points on the polar coordinate system. I wish I would have put, so polar coordinate system, you really just draw a normal one, and a lot of times we draw like concentric circles. And I'm actually not doing too bad on this one. Something to that effect. So well, I'm actually going to copy and paste it for the rest. Okay, like that, and then, okay, like that. Okay, so that's how you draw a pole. You just get a rectangle and add circles to it. Now R is 2, so we're gonna get to this middle ring here, and then my theta is pi over 3. So pi over 3 is essentially 60 degrees. So if this is 90, this is 0, or pi over 2, pi over 3, something like over here. But our real answer is the point right there. That is 2 pi over 3. Right? We go to angle of 60, then we go to a pole. That we're going to hit the pole of 2 from the radius. Okay, the next one. 3 and negative pi over 6. So negative pi over 6, right? It's like a negative 30. So it's going to be over. We're going to go from 0 down 30. So remember, when we're negative, we go down. So no, down 30. So we're going to be kind of like this. It's an estimation. We'll set the negative pi over 6. And then we have a radius of 3. So we're going to go 3 out for the center. So on that pole, 1, 2, 3. So right there. And the next one, 3 and 11 pi over 6. Well, 11 pi over 6 is probably the same spot. Right, we go, this is 6 over 6. This is 12 pi over 6. And then 1 less. So same spot, and we're going to go 3. So right there. Okay, before we move on, we should have another point. We should do the point negative 2 and we'll do 11 pi over 6 again. Let's talk about how what that does. We'll do it on the same graph. So let's graph negative 2 and 11 pi over 6. So what happens to the negative 2 and negative radius? We're going to still be on the same pole because it's still 11 pi over 6. Let's continue this graph all the way. So we're going to continue the line the whole way. And when it's a negative, you're not going to follow the proper angle like this way. We're going to go back. So 1, 2. So point right here would be the point negative 2 and pi over 6. So that's how negative radiuses work. So you go back on the pole. So positive radius, you go forwards toward the pole, toward that angle. A negative, you go backwards. A negative angle, just like a normal angle, right? Positive, you go up. Negative, you go down. A negative radius, you go back on the pole. Okay. Next, multiple representation of a point. So we want to plot this point, and we want to come up with 3 additional polar representations of this point. Okay. So let's do that. Do I still have my thing saved? Yes, I do. Haha. Okay. So negative 3 pi over 4. So here's 0. Here's negative pi over 2. Here's negative 4 over 4. So negative 3 pi over 4 would probably be like halfway through this. So we'll say that. I could do better than that. We'll say that is the pole for negative 3 pi over 4. Right, so we haven't got to here yet. So we're a little short. Negative 3 pi over 4 is right there. And then 3 would be the third ring. So that guy right there. So that's a normal one. That's what they gave us. That's how you do it. We want 3 other representations of it. Okay, first one, just directly. What's this in the positive angle? Right, so you could do a coulomb angle. You could add 2 pi to it. But let's just look at it, right? If we're doing a positive, this would be 4 over 4, 5 over 4. So one of them we could do 5 pi over 4 and 3. So that'll be the same thing, right? We go 4 over 4, 5 over 4, and then go 3 from the center. Now let's do a fun one with a negative radius. And I did this backwards, by the way. The radius goes first and then the angle. There we go. Okay, now let's do one with the negative radius, right? What if I want to go from here, but I want to go backwards? So I need to figure out what angle this is. Well, this is 4 over 4. This is in the first quadrant. This will be pi over 4. So I could do something like pi over 4 and then negative 3. Right, we're going, so we go to this line, but we have to go back 3. 1, 2, 3. Okay, for a third one, let's try to go double negative. Let's go negative angle and then negative going back. So I want to go all the way back to here. So let's go negative this way. So this will be negative 4 over 4, negative 8 over 4. One less would be negative 7 over 4. But then around this pole here, right, we want to go backwards 3. So 1, 2, 3, negative 3. So those are 3 different representations of the same point in polar. And we could do a lot more. Like we could do coulomb angles up the wazoo. Like we can keep on going around circles. But those are like those are some general ones, right? You could go negative angle, or you could go negative pole, or normal angle, normal pole. Okay, coordinate conversion. So we want to convert from one to the other. So if we first start off with r and theta, how do we make that into x and y? Well, in that case, we actually just have to use SOHCAHTOA in the triangle. So let's say this is our point x, this is our point r theta. I want to turn it into an xy. Well, look at that pole here. You can make it a triangle, and all I need is the x value, and I need the y value. Well, we could do SOHCAHTOA, right? Cosine of theta would get me x over r. It's like right here. Sine of theta would get me will give me y over r, like right there. And if you solve that for x and you solve this for y, like multiply both sides by r, you get this formula. X equals r cosine theta and y equals r sine theta. So that's it. If I give you a polar and you want the rectangular, all you have to do is plug into this formula, right? Because it all comes from making a triangle. So you make a triangle and basically solve for x and solve for y. If you're trying to go the opposite way, if you have x, y, and you want r theta, well, we got to find 2 things. We got to find the r. Well, if you look here, right, if you have an x and y, like you have this point and this point, how do you find the r? Pythagorean theorem. A squared plus b squared equals c squared. So you have to use that. X squared plus y squared equals r squared. Now you can solve that for r, like square root both of these, all that stuff. And how do you find the angle? Well, angle is just, I mean, you could do any of them, right? You could do sine, cosine, tan. But particularly if you have x and y, that's a tan. So we're going to have tan of theta equals y over x. And that's how you find r and theta, right? You have to do a little more work, but you're going to find theta from here. So you can do tan inverse both sides. You can find r from here. You have to square root both sides. But that's the general process. It all comes from making a triangle. And then here's the general formulas, right? So x equals r cosine theta, y equals r sine theta, and then tan theta and r theta. The one thing about tan theta, I will say, little apostrophe, you got to check the quadrants. Because remember, tan inverse only works in quadrant 1 and 4. So if you're in quadrant 2 or 3, you're gonna have to add either pi or 180 if in wrong quadrant. Because tan inverse doesn't get you those quadrants. So you gotta watch out when you do tan inverse. You have to make sure, first plot your point, make sure it's in the correct quadrant, because if it's over here, you're not gonna be able to get it. You have to add 180 or pi from one of these things. But if you're in the correct quadrant, you're good. Okay, so first one, convert this point to rectangular coordinate system. So this is my r and my theta. I want x and I want y. Well, if we know the formulas, x is r cosine theta, y is r sine theta. Right? Remember, x is cosine always goes to x, sine always goes to y, sine e. Now we're going to just plug it in. So this is going to be 2 and pi. So I get 2 cosine pi. I'm going to get 2 sine pi. Let's figure out what pi is. Here's 0, here's pi. It's on the unit circle. So that's negative 1, 0, x and y. Remember, cosine is x, so that's negative 1. So I get negative 2. And sine is a y, so 0, so I get 0. So this is the same point as negative 2 and 0. And let's check. Right, here's my polar system. If we graph pi and 2, well, pi would be over here, right? Here's 0, here's pi. Then we go 2 out. So right there is pi and 2. If we do a graph on the rectangular system, here's x, here's y. We'll go left 2, the exact same spot. So it works. Okay, let's convert this point to polar coordinates. So I'm going to need r, and the formula for that is x squared plus y squared equals r squared. So polar is r theta. And in theta, we have tan of theta equals y over x. Remember, tan is always like a slope, right? Slope is always y's on top. I don't know why, y over x. There we go. So we have this. So the first one is to plug it in. So we have negative 1 squared plus 1 squared equals r squared. So we get 1 plus 1 equals r squared. So 2 equals r squared. So square root of 2. So we get square root of 2. But we're always going to assume positive because we do a pole, we want to go out. Tan inverse. So we have tan of theta equals y over x, so 1 over negative 1. So we tan inverse both sides. You could use a calculator, you actually shouldn't need to. When does tan equal negative 1? So theta is going to be, right, negative 1 is down here, right, tan inverse, plus and minus, so negative 1 and 1, so that's going to be 45. Negative 45 degrees, sorry. Now remember what I said before. Whoops, let's put negative pi over 4. It doesn't matter which one. Remember what I said before, you got to check, make sure it's in the right quadrant. Is that in the right quadrant as we need? Because right now we're in quadrant 4, right? Negative 45 is in quadrant 4. Is that point in that quadrant? So let's graph it real quick. And we get negative 1 and 1, that is up there. So you can see it's not in the correct quadrant, right? That is not where negative pi over 4 is. Negative pi over 4 is down there. So it's an easy fix though. All you have to do is go back here and add pi. Or if we're doing radiant degrees, you would add 180. Because that's how we go from where we're at right now, which is down here, we're right there, to over there. You just add pi or 180. That's all it is. So it's an easy fix. Anytime it's wrong, you just add pi. You get it right back again. So that's over 1, so 4 over 4. I'm going to get 3 pi over 4. So that should be my theta. So my formula is going to be, my coordinate point is going to be r, which is radical 2, and then 3 pi over 4. Now again, there's lots of ways to represent that. If we wanted to stick with negative pi over 4, that would have been fine. We just had to go the negative. I'm trying to figure out how to get back there, right? So negative pi over 4, we had to do a negative rad 2 as our radius. So we're going to go there, right? Because we're on the wrong pole. We're over here. So you can make this part negative, fix it that way. Right, remember, there's lots of representations to it. So lots of ways to do it. But the general one is this one. That's what we consider the normal one. Okay, last little part here. How do you convert the equations? Now, one of them is really easy, just like before, right? Over here, going from rectangular to polar, kind of messy. We have to do a lot of stuff. But going from polar to rectangular, super easy. Just plug into these formulas. For the same reason, when you do the equations, it's actually the opposite. Going from rectangular to polar, super simple. All you have to do is, wherever there's an x, replace it with r cosine theta. Wherever there's a y, replace it by r sine theta. You can see here's an example here. So replace them, and you get this. And then you can just do some trig identities that we all love to get something like that, get r by itself. So it's super straightforward. On the other hand, going the opposite way, if you have polar and you want rectangular, it's a little more, you do a little more work. So describe the graph of each polar equation, find the corresponding rectangular equation. So we have to keep in mind that the equations we have to use are this. And tan of theta equals y over x. So like this first one here, r equals 2. What I could do is I could square both sides. And I get r squared equals r squared equals 4, like that. And now why did I do that? Because now at r squared I have r squared is x squared plus y squared. So I can replace this with x squared plus y squared equals 4. And you get your equation. That's a circle. B is a little tougher. I have theta equals pi over 3, right? So I can't use this first one. That doesn't help me, but this one does. What if I take the tan of both sides? If I take the tan of both sides, I can make this guy look like tan, and I know tan of theta equals y over x. So that's what we're going to do here. So for this one, we're going to take the tan of both sides. So we get tan of theta equals tan of pi over 3. Right, so I took tan, because I'm trying to match one of these guys here. So I took tan of both sides, tan of theta, tan of pi over 3. This guy equals y over x. Right, just following the formula right there. Tan of pi over 3, we can figure that out. Pi over 3 is a 60-degree angle. So rad 3, 1, and 2. Tan is opposite of rad hypotenuse. So rad 3 over 1. Right here we have equal signs, so we can just cross multiply. I get y equals rad 3x, or x rad 3. And that's our equation. So that's just going to be a line with the slope of rad 3. So there's that one, right? Okay, how about C? R equals secant theta. So the next one's probably the least intuitive. Actually, I need more space. Let's get rid of this. We got to bring out the other formulas too. X equals r cosine theta, and y equals r sine theta. So going this way, you're going to try to like use these to figure out what we get. Because right here I have r, but changing it, squaring both sides, and changing it to x squared plus y squared, but then on this side I have secant squared, which I don't think is going to lend me anywhere. But what I could do is that I know secant is kind of like cosine. So what if I do this? I make r equals 1 over cosine theta. And then I can multiply this to both sides. Or I can multiply cosine on both sides. And then we get, cancels out, we get r cosine theta equals 1. But r cosine theta is just x, right? That's what r cosine theta is. So this is just x equals 1. And that is a line. So that's how you convert from polar to rectangular. You have to play around with it a bit. Going the other way, so again, going from rectangular to polar, like if I gave you this, you just change x to r cosine theta. Done. Well, I have to get r by itself. Over here, right, you change x to r cosine theta, you change y to r sine theta, and play around with it a bit. But going the other way, a little more work. Anyway, that's the lesson.